Have you ever wondered what lies beneath your feet? Not just soil or rock, but something ancient, something that has witnessed the entire history of our planet. Wow! Deep within the Earth's crust, there are immense, stable, and incredibly old blocks of continent called cratons. These aren't just any rocks. They are the heart of our continents, the primordial foundations upon which everything else has been built. Think of them as the planet's time capsules, preserving secrets from billions of years ago. They are the supercontinents of the past, broken and scattered, but still here, holding the stories of Earth's fiery youth. So, what exactly are these mysterious geological giants, and why are they so important? Let's dig in and uncover the secrets of cratons. To understand a craton, imagine a massive, unsinkable raft of rock. These are the oldest and most stable parts of the continental lithosphere, which is the rigid outer part of the Earth, consisting of the crust and upper mantle. Cratons have survived billions of years of geological turmoil, the shifting of tectonic plates, the collision of continents, and the eruption of volcanoes, while other parts of the Earth's crust are constantly being recycled through subduction, where one tectonic plate slides beneath another. Cratons are too buoyant and thick to be pushed down into the mantle. They just float. This incredible stability is what makes them so special. They are made of strong, crystalline basement rock, often covered by a thinner layer of younger sedimentary rocks. The core of a craton, the really old part, is called a shield, where these ancient rocks are exposed at the surface. The surrounding areas, where the shield is covered by younger sediment, are called platforms. Together, the shield and the platform make up the craton. So, just how old are we talking? When we say ancient, we mean it. The oldest parts of cratons formed during the Archean Eon, which is a mind-boggling for 2.5 billion years ago. To put that into perspective, the Earth itself is about 4.5 billion years old. This means that some cratons have been around for almost the entire history of our planet. They contain some of the oldest rocks ever found on Earth. For example, the Acasta gneiss in the Slave Craton in Canada is over 4 billion years old. These rocks were forming when the Earth was still a young, hot, and volatile world, very different from the one we know today. There were no plants, no animals, and the atmosphere had very little oxygen. These rocks are our only direct window into that primordial time. They tell us about the conditions on early Earth and how the first continents began to form. They are the geological bedrock of our planet's history book, with each layer telling a story of a bygone era. Now, you might be thinking, if these things are so huge and ancient, where are they? Why can't I just go and see one? Well, you can, but you might not realize what you're looking at. Cratons are everywhere. They form the stable cores of all modern continents. For example, North America has the North American Craton, which includes the Canadian Shield. In Africa, you have the Kalahari Craton and the Congo Craton. Siberia, Australia, and South America all have their own massive cratonic cores. The reason you can't just see a craton is that they are continental scale features. You're likely standing on one right now without even knowing it. The parts where the ancient rock is exposed at the surface, the shields, are places you can visit to see these primeval rocks. Think of the vast rocky landscapes of central Canada, Greenland, or parts of Scandinavia and Finland. These are exposed cratonic shields. The rest of the cratonic shields, the rest of the craton, is buried under layers of younger rocks and soil, forming the foundations of cities, forests, and farms. So, while they might be hidden, their presence defines the very landscape we live on. Have you ever visited a place that you later found out was part of an ancient geological shield? Let me know in the comments where it was. I'd love to hear about it. The formation of cratons is a topic of intense scientific research and debate. The early Earth was much hotter than it is today, and the process of crust formation was likely very different. One leading theory suggests that cratons grew through a process similar to modern plate tectonics, where volcanic island arcs and small continental fragments collided and stuck together over millions of years. This process, called accretion, gradually built up larger and larger land masses. Another theory proposes that huge plumes of hot material rising from the deep mantle played a key role. These mantle plumes could have caused massive melting of the overlying crust, producing vast amounts of buoyant, silica-rich magma that solidified to form the thick, strong roots of the cratons. It's likely that a combination of these processes, and perhaps others we don't yet fully understand, were at play. What is clear is that once formed, these cratonic keels, the thick mantle roots extending deep beneath the crust, acted like anchors. These keels are colder and more rigid than the surrounding mantle, protecting the overlying craton from being easily deformed or destroyed. So why should we care about these ancient, seemingly inert pieces of rock? Cratons are incredibly important for several reasons. First, as we've discussed, they are our planet's historians. The rocks and minerals within them preserve a unique record of Earth's early environment, atmosphere, and the emergence of life. By studying them, we can piece together the story of our planet's evolution. Second, cratons are treasure chests of valuable mineral resources. The unique geological processes that formed and modified cratons over billions of years have concentrated some of the world's most significant deposits of diamonds, gold, platinum, nickel, and other precious metals. Diamonds, for instance, form under immense pressure and high temperature deep within the mantle. Conditions found at the base of cratonic keels. They are then brought to the surface by rare volcanic eruptions called kimberlites, which act as elevators through the stable cratonic crust. Without cratons, we wouldn't have these incredible gems. Furthermore, the stability of cratons makes them relatively safe from major earthquakes and volcanic activity. Most of this geological action happens at the edges of tectonic plates, while the interiors of cratons remain quiet. This stability has profound implications for long-term planning, such as the disposal of nuclear waste. Scientists consider the deep, stable geology of cratons as potential sites for permanently storing hazardous materials, where they can remain isolated from the surface environment for millions of years. This makes understanding their structure and long-term behavior a critical area of modern geoscience. The study of cratons isn't just about looking into the past, it's also about securing our future. In conclusion, cratons are far more than just old rocks. They are the very soul of our continents, the silent witnesses to nearly all of Earth's history. They are the indestructible rafts that have navigated the turbulent ocean of geological time for billions of years. From providing the land we live on, to hiding treasures like diamonds deep within their roots, to offering clues about the very beginnings of our world, cratons are fundamental to understanding planet Earth. The next time you walk on solid ground, take a moment to think about what lies beneath. You might be standing on a piece of a lost supercontinent, a remnant of a world that existed billions of years before the dinosaurs, before the trees, before even the air we breathe. These ancient foundations connect us directly to the deep, dramatic history of our incredible planet. Thanks for joining me on this deep dive into the heart of our continents. If you enjoyed learning about cratons, be sure to hit that like button and subscribe for more adventures into the wonders of our world. See you next time.